Good afternoon, everyone. My name is Arjun and I am studying at Native Nanchi Institute of Technology. I'm currently studying Artificial Intelligence and Data Science Engineering. Today, for my Samsung Innovation Campus program, I have built a project. It's called Industrial Defection Detection System and Maintenance Recommendation System. It is an AI system which processes images at industry objects and detects anomalies within them if they are present. This project was done because manual inspection is very inconsistent, expensive, and time consuming. So to solve this problem, I've created this AI system. Yeah. So this project has tech stack which uses for backend, it uses PyTorch, Touch Vision, OpenCV, and for feature extraction, I've used YDRES Net 50. And for the main anomaly detection, which is the core of the model, I've used a pre-trained model called PatchCore. And to connect APIs, I've used Fast API and SQL Alchemy, which connects Python to databases, and Report Lab for the report building. Front end, I've used React, Tailwind, CSS, and for database, PostgreSQL. And testing was done in manual testing first, and then I shifted it to PyTest. And deployment, I put all it in a Docker container, and I will run it. So the main feature of this is, once an image is uploaded in the thing, the PatchCore is trained based on good images, defect-free images. So it trains on multiple of good images, and it builds a memory bank out of them. The memory bank has the collection of all the good images. And once all the good images are present in it, it calibrates it. There's a calibrating program which gives a measurement of how good the product is. And so that it uses the calibration data to find out anomalies. So if a defective product is there in the model, it will check with the calibration unit, and then if it's not consistent, it detects it as defective, and then it gives a severity report. Severity report shows how severe the defect is, and based on how severe the product is, it gives out a recommendation. So whether to reject it or to move it, or if there is any changes to be done. So I will show you how it works now. Yeah, this is the website. So the database consists of 15 categories, from bottles to zippers to crates and hazelnuts. So I will use an example of a bottle. Yeah, as you can see, it generates a heat map. And what it flags it as a containment. There's something within the bottle, and so the PatchCore identifies that, and then it marks it it gives it an anomaly score. So if the anomaly score hits a certain criteria of like around 40%, it tags it, and then it gives a severity report. As you can see, it says critical here. And based on that, it gives you recommendation actions. So the recommendation actions are reject product, inspect conveyor alignment, recalibrate machine, or schedule urgent maintenance. And then once this anomaly report has been done, you can download it. And once this is downloaded, you get the reports of what the defect was and what are the ways to improve it. There's also a dashboard which shows all the inspections done, anomaly scores of all the products. So in an assembly line, multiple products can go through, and if there is any defect, it checks out the defective percentage. So if there are 100 products of the same thing and 20% of it is defective, so the anomaly defect rate will be 80%, like 20%. And average anomaly score and how many categories are tracked. In this, I've already tried 5 categories, and then it shows the recent score trend. So how bad the anomalies are, it makes a graph out of it. And then the dashboard also has the recent top 5 graphs which I've already tested out. And then it also checks the history. Because it's connected to a database stores all the this anomaly heat maps, and then it shows categories, ID, score, severity, how bad it is, and timestamp on when the heat map was generated. And then if you do want to access that, you can always download those files. I'm going to show you the code base now. Yeah. I divided the code base into a backend, front end, models, reports, and documents. Documents contain all the evaluation reports, heat maps generated, and then front end contains all the front end part. Backend contains all the testing, APIs, database structures, and data sets. And then I'm going to show you the evaluation report of the model. Each category went under a graph, AROC graph, and because some graphs patch code is because it's a pre-trained data, it needs for lower accuracy models, like lower accuracy objects, it needs a higher memory bank. So for the lower accuracy, I've increased the memory bank, and it has to keep updating. It has to have a bigger memory bank, but the data set was very limited. So that's why the last two, toothbrush and grid, had lower AROC graphs. And then there was also a calibration unit. I started with bottle as a main category, and so that was calibrated specifically, like to one object. So bottle had a specific calibration unit to train the patch code model. But then, because I had to do all the 15 categories, I made a Python script for all the general categories. So it had a general calibration unit. Yeah. So those, yeah. After that, changing those calibration fixes, I got a upgrade in recall. Recall increased after I changed the calibration unit. As you can see, the red, it was the previous one, and then the green increased the recall, and thus increasing the AROC. The average AROC and precision for the model is around, as you can see here, for each category, it reaches around 90%. The reason it's low is because the memory bank needs to be increased so that the model is used to it. And for those specific grids or categories, it needs to be trained more. These are the confusion matrix for bottle and capsule. Capsule is the generated, similar calibrated ones, and bottle was the specific calibrated script. As you can see here, average precision is 95 and average AROC is 92%. The easiest category for the model to be understood is leather, and the hardest one was grid, because it couldn't have it needs a larger database to find out the anomalies. Yeah, so that's it. That was my project. Thank you.